8th grade, Algebra 1. This is Mrs. Sigley. I am continuing with the examples for real-life situations for exponential functions. So in this second example, Sydney deposited her birthday money of $1,250. Here's your big hint, deposit it. So because you're depositing, it is a growth situation. You want to put your money in the bank so that way it can grow. And what she did was she deposited $1,250. The bank told her, hey, we'll give you a rate of 4.75% compounded yearly. She did not make any more deposits. She did not make any more withdrawals. She kept it there, and she kept it there for 5 years. So the equation that I'm going to substitute everything in is going to be y equals to the principal times 1 plus the rate to the power of x. What was my initial amount? Sydney had $1,250 to put in the bank. What did the bank tell her? That the rate was going to be 4.75%. And in this example, I'm going to change it to a fraction. And so that fraction is going to be 4.75 over 100 because of that percent sign. Then, what's my factor? My factor is going to be 1 plus 4.75 over 100. Or if you've already calculated this right there, that gave you 0.0475. So it would be 1 plus 0.0475, which comes out to 1.0475. So be very careful. On your assignment, when I ask you for the rate, I'm going to be asking you for this part right there. If I'm asking you for the factor, I'm going to be asking you for this part. Very two different things. So be on the lookout for that. Then what's the time? Here I didn't have to figure out anything right away. 5 was the number of years. So all you do is you substitute. So y equals to 1,250 times 1 plus, and I'm going to keep it as a fraction just to show you both ways, 4.75 over 100 to the power of 5. So you get your calculator, and I'm going to enter just that. 1,250 parenthesis out 1 plus alpha y equals, enter 4.75 over 100, jump out, close your parenthesis, to the power of 5. Enter. So at the end of 5 years, Sydney's going to go back to the bank, and the bank is going to give her $1,576. And because I'm talking about money, I'm going to round this time around. So therefore, it's going to be 0.45. So I took that and I rounded it to 45 cents. The next example that I want to show you is fixing my papers. Lake Amistad has a fish population of 8,000. So right away, that's my initial amount. But due to the hot weather in Del Rio, the fish population is decreasing. So I know that's a decay. And I know that I'm going to be using y equals to the principal times 1 minus the rate to the power of x. And it's decreasing at a rate of 6% each year. So what's the fish population going to be in 10 years? So I'm going to fill in those blanks. What was my initial amount? 8,000. What was the rate? 6%. And I'm going to change that to a decimal of 0.06. That's my rate. What's my factor? So my factor is going to be 1 minus 0.06, which is going to come out to 0.94. So be very careful when I ask you the question on your assignment. So either I'm going to ask you what the rate is, and so the rate is just changing it to a decimal, or I'm going to ask you what the factor is, which means you must subtract or add that rate. Very two different type of answers. Then what's the time? Here it was flat out 10 years, and then I'm just going to plug in y equals to 8,000 times, and you could do it either or. I'm going to put 0.94 since I've already done the hard work, to the power of 10 years. But if you wanted to and you didn't want to do that work before, you could do y equals to 8,000 times 1 minus the rate to the power of 10. You could do either or. It doesn't matter. So I'm going to get my calculator. And so it's going to be 8,000 times 0.94 to the power of 10. And so since I'm talking about animals, I'm not going to round. So therefore it's going to be 4,308. Okay. The next example and final example is that Rachel bought a car, a 2020 car. So her friend Carol told her, hey, that's a bad decision because cars depreciate. So right away, they're telling you that it's depreciating. And so that's a key word for decay. And my equation is going to be y equals to the principal times 1 minus the rate to the power of x. And it's depreciating at a rate of 10%. Rachel didn't listen, so then she still spent $36,000 on her car. So Rachel finished her 4 years of high school. She went 4 years of college. So at the end of college, 8 years later, what's that car going to be worth? Is it going to be worth the $36,000? So what was my initial amount? Rachel bought that car for $36,000. What was the rate? Cars depreciate at a value of 10%. I'm going to change that to a fraction this time. So it's going to be 10 over 100. What's my factor? So I told you that you could do it two ways. 1 minus 10 over 100. Or if you've already calculated this, this is 0.10, and it would be 1 minus 0.10, which your factor is 0.90. So very two different things. If I ask you for the rate, it's 0.10. If I'm asking you for the factor, it is what you're going to be adding or subtracting the rate. In this case, we subtracted the rate, which is now my factor of 0.90. What's my time? 8 years. And then I'm going to plug in y equals to 36,000 times, since I already did the work here, I'm going to put 0.90 to the power of 8. But if you didn't want to do the work, then you would just write your equation as y equals to 36,000 times 1 minus 10 over 100 to the power of 8. However you want to do it. Then you get your calculator, and I'm going to enter 36,000 times 0.90 to the power of 8. Enter it. And so 8 years later, that car that Rachel bought for $36,000 is now only worth $15,496. And because I'm talking about money, I'm going to round it to 0.82. So therefore, the most important question is, should Rachel have bought the car? I would say no. Did Carol give her good advice? Yes, because it loses a lot of value, depreciation. So those are the examples. Those are real life examples of using the exponential function. So be very careful. On your 10 problems, I'm going to be asking you for the rate or for the factor. These are the two most important ones. So good luck on your assignment, and we will see you next week when we are going to be transforming the exponential function. And that's the last lesson of exponential functions, and then we're going to begin reviewing once again. So we'll see you next week. Bye.